if the maintenance and servicing is not done properly, if they have used spurious parts because of the cost implication, or if they have done hard acceleration, if they use very bad driving practices, engine is tempered because of various things, then engine is going to perform bad. Therefore, you will find a good engine, well-designed engine by the OEMs, well-tested engine by institutes like ARAI. When it goes in the hands of common men like me and you, and we don't take care of it, it starts smoking. Therefore, actual real-life performance is completely different than the lab performance, ideal condition performance. In BS6 equivalent from 1st April 2020, one more regulation that has come in is the real-life emissions should have some factor with respect to lab emissions. We call it RDE, the real drive emissions. And this is the first time happening in our country. In Europe, it started in 2017, and good thing is that India is not lagging behind. We are only 3 years, and it is only possible because India leapfrogged from BS4 to BS6 directly, jumping through BS5 because we wanted to avoid the issue of real-life emissions completely different from the laboratory emissions. Therefore, when we have to now design BS6 engines, which we did and some OEMs did, while doing the tuning of that engine to meet emissions from tailpipe, we have also tuned it electronically and various other means that real-life emissions are not very widely different from lab emissions. Today, the factor is probably in the range of 1.6 or 1.8, and final destination is to reach unity, so that emissions at lab and emissions in the field is same. But it is going to be a very hard task. And while doing that, what we have to do? We have to go with different advancements in combustions, like we must be hearing about homogeneous combustion, pre-chamber combustion controls, low temperature combustion controls, GDI, gasoline direct injection, gasoline combustion in compression ignition mode, GDCI we call it. These are the new combustion concepts we are working, everybody is working, so that we can excel the thermal efficiency, at the same time reduce the emissions coming out of it. Then various variability we bring into the engine, we can tune the performance as per the given requirement. Variable compression ratio, variable swerve, variable timing, variable actuation, variable lift, all these kinds of variability, Miller cycle, so that we can increase the expansion work at the end of the thermodynamic cycle. They're all employed, but everything comes with a cost. And all these after treatment systems like SCR and DPF, which is a costly affair, how can we optimize the size and volume and its loading, which is because we use precious metal into it, how can we optimize its utilization? That work is also going on. And while doing that, engine should be as small as possible to do the same work, which is called as downsize, that is more power from the same liter of the engine is work. And at the same time, engine speed reduction. Reduce the engine speed, do the same work, so that lower the engine speed, lower the friction, lower the losses, and we can get good fuel economy. So such challenges are there. I'll not go into detail of this. Therefore, pragmatic approach is an ideal engine and a combination with the ideal fuel through the route of ideal combustion and achieve the ideal performance out of it. Finally, when we are talking about hydrogen as our final destination is electrification. All mobility transportation in future finally will be electrified, because that is the only source when we can avoid fuel at all, and when there is no fuel, there is no combustion, and when there is no combustion, no tailpipe emissions. But how to produce the electricity is a big question mark. Again, there are many things we can speak for several hours on that. But let us assume that it is going to be the final destination. Now, one of the methods of achieving electrification completely is only possible when you get the electricity from a renewable sources. Either it can be wind energy, solar energy, as was given in one of the theme, various energies that are available, but they are going to be far-fetched situation from us. So one of the things as a fuel that is available is hydrogen, which can be used directly in the combustion as a combustion fuel, but it has got a lot of limitations. Or hydrogen can be used in the fuel cell, where the hydrogen in the fuel cell can produce electricity, and that electricity is fed via battery to the motor, and then that motor is giving power to the wheel. ये हमारा final destination है. Therefore, hydrogen fuel economy is connected to the full electrification of the powertrain in transportation business for next 20, 30, 40 years of development. Many advantages, many disadvantages of the hydrogen today, because one thing is that hydrogen is not available as a crude. It has to be produced either by electrolysis or by some other means, or whatever fuel we have today, we have to reform that fuel into hydrogen. Then we have to package it, store it either in the liquid form or in the high pressure form. Safety is attached to the hydrogen. We know hydrogen flame is invisible. Even if flame is there and we enter through the flame, unless we get burned, we will never know that there is hydrogen flame because it is invisible. So there are many things from safety point of view, storage point of view, handling point of view, today cost point of view, many things. But this is the final destination, that we have to all work in that direction. I'm sure one day, even in maritime business also, this hydrogen fuel economy, electrification will be the destination, because every sector will face this problem one day or other. So when it comes to hydrogen economy, I think this is one of the major area open to all of us to work in that direction and do the excellence. I will not go into detail of all these slides again, but converting the hydrogen through electrolysis process on board in a vehicle, or reforming in the refinery somewhere, and pack that hydrogen in the cylinder and push those cylinder into the vehicle, carry along with the vehicle, and then use that hydrogen in the fuel cell, forming the electricity, and then they give this to battery for storing it, and then run a motor and give power to the wheel. Is the whole scenario that is going to be there in front of us as a visible future, and we have to work in that direction. The main advantage of hydrogen fuel economy is that since it is hydrogen without carbon, the tailpipe emission is only water vapor. So this is one of the major advantage as far as the hydrogen is concerned. Therefore, everybody is eyeing on it. Hydrogen can be used in the fuel cell directly. It can be of two types of fuel cell. One is called PAIMS type of fuel cell, another is called the SOFC type of fuel cell. These are the two fuel cells in front of us as a technology. Everybody is working in that direction. Air is also working in that direction. The only difference between two is that PMS type of fuel cell requires 99.99% pure hydrogen, which is very hard to manufacture cost-wise and all that. And SOFC has got one advantage. It doesn't require that much of pure hydrogen to work it. It can use not only hydrogen but other fuels also directly. Like it can use CO. If we burn hydrogen in air, and if we burn methane in air, it produces hydrogen, and it also produces as a byproduct some carbon monoxide. Even carbon monoxide can also be used as a fuel to SOFC based fuel cell. So therefore both the fuel cells are having their own merits and demerits, and we are trying to work in both the areas, giving more emphasis on SOFC types of fuel cells for transport applications. In summary, mild hybrid, fuel hybrid, plug-in hybrid, electric vehicle, fuel cell cars, vis-a-vis conventional IC engines have got various pros and cons, and for different segments and different applications we have to choose what is right for what, and accordingly that will be the fit powertrain for that sector. While doing that, we know battery electric technology is going to take its own time, and today's IC engines have got a lot of limitations from a tailpipe emissions point of view. Fuel quality is not under control. Therefore, synthetic fuel, as I talked, one of the fuels, DME or other e-fuels, are going to be one of the futuristic fuels for all of us, and we need to work hard in that direction. From production point of view, from again storage point of view, and all those things. So synthetic fuels, I see a future for all of us. While working on engines alone is not enough, we have to do a lot of work on transmissions, manual transmission, automated manual transmission, automatic transmission, constant variable, continuous variable transmission, CVT, dual clutch technology, DCT. These types of new transmission systems are coming up, and it has got associated improvement in the efficiency, associated advantage in the transmission ratios, etc., etc. So with respect to that, cost, weight, performance, packaging, comfort, luxury of utilization, different transmission systems are coming up. In terms of vehicle design, performance, fuel economy, NVH, safety, reliability, through suspension design, brake design, cabin cooling, aerodynamics, vehicle structure, main structure, tire technology is also becoming very important. Because tire technology is the only element which connects the vehicle to the earth, and it has got rolling resistance issues. Therefore, tire treading design, rolling resistance control, rolling resistance reduction is required to be done, tuned for a given vehicle weight and speed requirement, so that finally the fuel performance of the engine, VSFC performance of the engine can be achieved in the actual vehicle fuel economy targets. In front of India, the problems that we have is traffic congestion, bad maintenance of the vehicles, fuel quality control. Yes, there is some improvement now, but still there is a control issues because of mixing and quality controls. Unsafe road conditions, bad road conditions, poor road signal synchronization. Every 1 minute you have to stop because there is no synchronization of the traffic signal. More and more you do idling, more fuel consumed, more emissions we emit. There should be synchronization of the traffic signal. Public transportation has to be improved. I think a lot of work is going on so that private transportation is reduced. Then new technology and old technology of the vehicles are coexisting in our country. Today, even if you are going to bring BS6 technology vehicle from 1st April, you will be only 15%. Remaining 85% will be old, as old as 15 years old or 20 years old vehicles. In a glass of water, if you put 3 spoons of salt, for example, and 1 spoon of sugar, still that water will be salty in taste. So unless we remove salt completely or add at least 3 to 4 spoons of sugar, taste will not change. That means unless we remove the old vehicles, old technology vehicles from the scene, whatever new technology vehicles you bring in, it's not going to add to the improvement of the air quality. Therefore, disposal of the old vehicle, end of the life of the old vehicle is very important, for which policies are required to be framed. And in our political scenario of India, where there is a politics by vote, nothing is possible because there is always connection to the common man, and removing the old vehicles from the scene requires support from banking structure, OEMs and all that. But unless it is done, we are not going to achieve anything out of it. It's only an expenditure. Rough and hard driving habits, hard accelerations, very bad performance, safety, and overall social culture of aligning ourselves to the advanced technologies in front of us. One example, railways are bringing good coaches with lot of luxuries, and we hear that the new LSB coach train was put on the platform. Some people came and they broke everything. They stole many things out of it. This is the culture. If you are bringing high technology, electronically controlled, feedback controlled vehicles with us, and we are not going to use it properly, we are not going to get the performance. So our culture, our driving habits, our social uplift has to be aligned with the technologies that we are trying to bring. Unless they are aligned, result will not be what we want. So skip all these things. So what is way ahead? A lot of things in front of us. Further improvement in the combustion, new technologies, coexistence of the old and new technology has to be properly handled. Then diesel will not go. That much is sure to us. Next 30 years, new fuels will come in. We have to work on design features suitable to the new fuels, new transmission systems. This is an important slide from my side. While a lot of advancement is coming in mobility, not only limited to mobility in all sectors, because those themes that I have seen, I found that it is very good alignment with the level, land transportation also, a lot of electrification, autonomous driverless driving, a lot of intelligent transport systems, shared mobility and connected mobility. All these things are going to happen year by year in our country. But what is important today, anything, any new technology which is directly going to control emissions, improve efficiency, improve safety. Today we don't want luxury as such, but these 3 things, if we are able to achieve by any means of advanced technologies, they are welcome, and then only the last item will be the luxury. But unless they are supported by the infrastructure, traffic signals, roads, bridges, flyovers, good road conditions, road markings, road furnitures, nothing is going to be finally achieved. Future technology options, therefore, in front of us is a menu card. When we go to any restaurant, there's a big menu card in front of us. What is good to our health, what we can digest, what is prescribed because of several reasons is what we choose. Therefore, anything that is available in the menu card is not going to be liked by us. We have to be very choosy. And while doing that, we have to do a good brainstorm for every sector. Two-wheeler के लिए क्या अच्छा है, फोर-व्हीलर के लिए क्या अच्छा है, गुड्स ट्रांसपोर्ट के लिए क्या अच्छा है, मीडियम के लिए क्या है, स्मॉल के लिए क्या है, बस के लिए क्या है. Bus, what is good for city bus, what is good for official buses, what is good for interstate bus transportation, what is good for off-road, what is good for tractor, what is good for generator engine application, what is good for industrial application, what is good for aeroplane, what is good for boats. ARI has started working on water-based engine development also nowadays because India is looking for good number of transportation through waterways. So we are now working in that. Locomotives के लिए क्या ठीक है, airplane के लिए क्या ठीक है. So we have to go by choosing the segment and technology for it. N number of things are available in front of us. Choose the right one. So too much busy slide. Time is also finishing. So a lot of things are there. I think I will leave it to people to digest. I can only say at the end that for different segments of passenger cars or transportation, mix of IC engines, electrification and hybridization is available. We have to make sure. And this is the chart which we prepared in ARI as a roadmap for India for different segments from two-wheelers to industrial. What combinations of powertrain should be brought up so that it focused technology development is done for that with affordable cost and acceptable to the end user from the performance point of view. Therefore, what do we see? Several technological options are there, several combinations are there. There are many different driving forces which we have to meet and fight with. Several customer perceptions are there because we have to meet customer perceptions. Unless these are met, we will not be in the market. And several local real field aspects to be considered, whether it is political, policies, social or any kind. Therefore, the quote which I will be very happy to share with you, that fire can cook our food, we know, but it can burn our body also. That means it has got a double-edged sword test. Similarly, any technology has got merit, any technology has got demerit. We have to choose from its merits and demerits what is right for what, and then only we can say by choosing the right solution is our aim, is our task, because the right technology matters, and then only we can say plate in front of us, menu card in front of us, we can find right solutions for future mobility in different sectors by achieving the right powertrain mix. And I always believe that it cannot be done by any single individual, by any single team, by any single discipline of engineering. We have to work together. Then only we can achieve the final performance, because our great Abdul Kalam ji has always said, technology, unlike science, is a group activity, and it is not based on individual intelligence, but on the interaction